Let's look at another example of such a conversion. This time let's try a number 122.351 in the base 10, and let's convert this into a number with base, let's say 8. Okay, now just like last time, we're going to split this into two parts. So we have 122 and we have 0.351. Now with 122, the natural number part, we will use the standard table that we do, right? So we are going to divide 122 by 8. We get 120, the remainder is 2. Then we divide by 8 again, 8 1 the 8, and we are left with a remainder 7, and 8 0 the and remainder 1. So we have 172 in the base 8. So 122 in base 10 is equal to 172 in base 8, right? Now let's look at this decimal. Now 0.351, we'll multiply this with 8, we get 2.808, right? So we'll pick up 2 from this part. Then whatever is left, 0.808, we multiply this by 8, we get 6.464. So we pick up 6, right? And we multiply 0.464 with 8 again, and we get 3.712. We pick up 3, right? And then we multiply 0.712 with 8, and we get 5.696, and we pick up 5 from here. So we got all of these digits in the decimal places, right? So 0.351 in decimal is approximately equal to 0.2365, and it is continuing to the base 8, right? So we add these two up, right? From here we know that 122 base 10 and 0.351 base 10 must be added to get this number. So the answer is 122.351 in decimal is equivalent to 172.2326. I'm sorry, this should be 263. So 2635 in the base 8, right? Hope this part is clear. Now moving on, let's talk about the addition and subtraction of numbers in different bases, right? Now before we take addition, subtraction, let's first understand how the numbers in different bases, how they look like, right? How they appear to be in terms of their digit representation. Let's look at base 6. Now a number in decimal 0, right, is 0 in base 6, and that exact thing 3 4 5 6, right? All of these numbers in decimal, they continue to convert into base 6 numbers as follows, right? So 0 is 0 in base 6, 1 2 3 4 and 5, right? So until 5 there is no problem, but 6 in the in decimal, let's see how 6 converts into base 6. Now to convert 6 of decimal into base 6, we divide it by 6, 6 1 the 6, there is no remainder, so 6 0 the 0, and there's one remainder, right? So you notice that the base 6 is written as 10 in the base 6 notation, just like in decimal the base is 10, right? So 10 is the representation for 10. Exactly like that, in base 6, base is 6, so the number 6 is represented by 10 in this notation. So the number the number 7 in decimal is going to be represented by 1 1, right? So this is the 7 of decimal system, right? And 8 of decimal will be 1 2, 1 ahead, 9 will be 1 3, 10 will be 1 4, 11 will be 1 5, right? But as soon as we come to 12, right, the number 12 is going to be represented by no remainder, and 602, right? So the second multiple of the base is represented by the digits 20, right? Likewise, if we continue this, so we have, so this is 6 in decimal, this is 12 in decimal, so the number 13 in decimal system will be represented by 21 in base 6, right? And 22 and so on to 5 and 30, right? So this is 18 of decimal and 31 and so on until 40, then 41, right, until 50 and 51 and so on until 55, right? Now we are talking, this number is 24, this number is 30. Now we are talking the representation of 36, right? So 36, it converts into 6 6 the 36, no remainder, 6 1 the 6, no remainder, and 6 0 1 remainder, right? So notice that 36, which is the square of base, is represented by 100, right? So it is fairly straightforward to see that the base will be represented by 10, the second multiple of the base is going to be represented by 20, the third multiple of the base is going to be represented by 30, and the square of the base is going to be represented by 100. By this logic, the number 6 cube in decimal, right, which is 216 in decimal, is going to be represented by the digits 1000 in base 6 and so on, right? So if let's say somebody asks us what is the number 4, right, in decimal equivalent to in, let's say, base 4. So because this is the base itself, it is going to be represented by digits 10 in base 4. How about 8? 8 of decimal. It is the second multiple of the base, so it is going to be represented by 20. How about 16? 16 is the square of the base, so it is going to be represented by digits 100, right? Now hope you know this notation, how the digits how the digits are used in different bases is clear. Now with this background, let's do some basic addition subtraction. Now let us say we are given two numbers, 25, let's say, in base 6, and this must be added to, let's say, the number 13 in base 6. Now one of the ways could be to convert them to decimal, do the arithmetic and reconvert them back into the base 6. Now 25 is equivalent to 17 in decimal system, right? You can do your conversion. So you have 5 plus 2 into 6, which is 12, 12 plus 5, 17. And 13 is represented by 9 in decimal system, right? So you have 17 plus 9, 26 in decimal system. So 26 is represented by digits 4, 2 in the base system 6. But is there a way we can add these directly, right? Now to do that, let's look at how we had designed the table of these numbers. So 25 in the base 6 and 13, both of them in the base 6, right? When we add them, so 5 plus 3 is 8, right? Now 8 in base 6 has the notation 1 2, right? 8 is 2 above 6, right? So 1 2. So we just write 2 and carry 1 over, and we have 1 plus 2 3 and 1 4, right? So what we've done is the 5 plus 3 8 of the decimal, we use the base 6 notation for 8, which is 1 2. We kept 2 here, and just like we do a simple addition, we carried 1 over and it became a 1 plus 2 plus 1 4 4 2 in base 6, right? So this is how we've directly added these two numbers. Let's take another example. Let's say this time we have 421 in the base 6, which must be added to 323 in base 6, right? Now what we do here, 1 plus 3 is 4, that's not a problem, right? So 4 is still 4 in base 6. 2 plus 2 is 4, again not a problem, 4 is 4 in base 6, but 4 plus 3, 7 is 1 more than the base, so the notation for 7 is 1 1, right? So we write 1144, right? So 1144 in the base 6 is equivalent to this sum. Let's do another example. This time let's take 555 plus 231. Both of these are in base. This time again let's take base 6, right? Now this time 5 and 1 6, they add up to 6 in decimal, but 6 in decimal is 1 0 in base 6, so we write 0 and we carry 1 over, right? So we have 1 plus 5, 6 and 3, 9. Now 9 is 3 above the base 6, so it is represented by 1 3 in base 6, so we write 3 and we carry 1 over. We have 5 and 1 6 and 2 8, 8 of decimal, but 8 of decimal is represented by 1 2 in base 6, so we just write 1 2 3 0 to the base 6. That's the equivalent of this summation, right? Now let's do some subtraction. Now for subtraction, we are going to use the same concept that we use when we subtract two numbers in decimals. The only thing is, when we are going to borrow something, we are going to borrow something which is equivalent to the base and not 10, right? So let's say we have to subtract 33 in base 6. From 33 base 6, we have to subtract 15 in base 6. Right? So now 3 minus 5 is not meaningful. So I have to carry 1 over. But when I carry 1 over, that 1 is actually equivalent to 6 and not 10, right? So it doesn't become 13 of decimal. It becomes 6 plus 3, 9 of decimal when I carry 1 over, right? So carry 1, which is equivalent to carrying 1 from tens to ones, is equivalent to carrying 6, right, of decimal. So 6 plus 3, 9. Now I can subtract 5 from 9 and I get 4. Right? So 9 minus 5 is 4. Right? And 4 is the same representation in both decimal and base 6. Now this 3 is, because it is given 1 here, so 3 is left with 2. So we have 2 minus 1, 1. Right? So we have 1 4 in the base 6. Now let's verify this in decimal. 33 in the base 6 is actually equal to 21 in base 10. 15 in base 6 is equal to 11 in base 10. When we subtract, we get when we subtract 11 from 21, we get 10 of base 10, right? And 10 of base 10, right, this number is equivalent, is 4 more than the base 6 here. So we have 1 and 4 representing the number 10. So our arithmetic is absolutely correct, right? So that's how we do subtraction. Whenever we carry 1 over, it is going to be equivalent to the base. Then you do your conversion and then you write whatever is the outcome in the base, as is in the base of which we have to find the answer.